Okay, so I want to talk about the two problems that you have to do for this week, which is Slurpy and vacation. So we start Slurpy. Okay, so in this problem, you have three different things that they define. Something called slump, something called a slim, and something called a Slurpy. And these are all strings that, and if you're asked, is this string a slump or a slim or a Slurpy? The answer is either true or false, right? So what you should do, okay. So what you should do is look at each of these three things and write a function that will take in a string and return true or false. So you have slump, string, s, and bool, okay. And you can have basically one function like this for each one. So what is a slump, right? If somebody gives you a string and you have to answer is it a slump or not, well, you look at the definition. It has to start with a D or E. Okay, so one of these. I made it like this. And it has to be followed by a string of one or more F's. I made it like this. And then it's either a single G or it's followed by another slump. Okay, so of course if it's single G, you can just check it quickly. But if it's not a single G, then you basically have to strip out the first D or E, all the F's, and then recursively call slump and ask if it is true. If it becomes true, then yes, you found it. Otherwise, it's not, because this rule number 4 says nothing else is a slump. Okay, what is about slim? It starts with an A. If it's a two-character slim, then it's A and H, like this. Otherwise, it could be A, B, followed by a slim, followed by C, or it could be just A, followed by a slump, followed by C. So again, let me make this look a little bit nicer. So again, what you do is you basically strip out the first one or two letters, depending whether you're the first case or second case, strip out that slot C, and then recursively call the correct function for the middle part, and then it either can tell you yes or no. And then finally, Slurpy basically is a slim. Let's see, what is slim, followed by a slump. So you have to ask yourself, can your string, whatever string that they give you, can it be written into two parts? First part is a slim, second part is a slump. Well, how do you know? Well, you have to basically cut it in all possible ways. And for each way, you ask it recursively, is the first part the slim, is the second part the slump? If any one of them returns true on both parts, then you know that you have the correct breakup. And that's a Slurpy. Okay, now, this is not the most efficient way of doing things, right? Because you might end up looking at the same substring over and over again in different ways. But because the number of characters here is only 60, that's definitely sufficient. Okay? If you really want, you can look at the rules carefully and realize that there are certain things, like for example, if G somehow only ends, slump, so if you can say find a G and then you can break things up, and you can look at the rules and maybe be more efficient, but then you have to think a little bit hard, okay? But since it's only 60, efficiency is not really a big concern. Okay, now I want to look into the other problem that you have to do, which is vacation 10912. Vacation 10192, sorry. So here you're given two strings, okay? How many? 101. And they're not very long, okay? this on my screen. I guess you can't see my screen. Anyway, and so you have two strings, let's call them S and T, and each one of them has at most length 100. Okay, and what you want is the longest common subsequence. What do I mean by that? So if you look at the first example, A, B, C, D, A, C, D, D, if you remove, let's say, the B, then the two are the same, right? A, C, D is left. So a subsequence is simply what happens when you remove some characters. So the remaining characters stays and it's the same order as the original appear in the input. And you want the two subsequence to be, first of all, common, they're the same, and they have to be as long as possible. Okay? So this is a classic dynamic programming problem. Let me erase that. Let's do this. And we're going to say that f of ij is the length of the longest common subsequence of the first string, let's call it S, from 0 dot I. Oh, sorry, let me change it in the full S0 dot I minus 1 and T0 dot J minus 1. In other words, Fij is solving the problems when the string are the first I characters of S and the first J characters of T. Okay? So the base case, it's simple. If either one of the string is empty, then the longest common subsequence is 0, right? Because there's really nothing other than empty string. The recursion step is a little bit trickier. And I'll just draw a picture first. So you have the first I characters of S. So this is I minus 1. And the first J character of T. Okay, they don't have to be the same length. And I look at this last letter. If they're both the same, then whatever longest common subsequence I have for the first portion, I just add 1, because I can always attach A to the end of both subsequence and it will be the right thing. It will be the longest one. If, on the other hand, these two are not the same, then the longest common subsequence cannot contain both. It can contain one of them, but not both. Which one? I don't know. Or maybe none of them. So the recursion looks like this. Fij, it's equals to Fi minus 1, J minus 1 plus 1 if S of I minus 1 is the same as T of J minus 1. Okay? If the two characters are the same, I can just recurse. I'm sorry, this is not very good handwriting on my tablet here. Okay, otherwise, if they're not the same, then I have to drop one of them. But which one, I don't know. So I'm going to try dropping the first one, or I'm going to try dropping the second one, and I'm going to pick the maximum of these two. Okay, whichever one comes back as the maximum, that's the answer. So you build this table, which has, of course, basically 100 and 100 on each index. So it's a 100 by 100 table. You run top down or bottom up dynamic programming, whichever way you want. And the answer that you get, basically you compute f of the length of the strings, two strings, and then the answer you get is the answer that you have to print. Now the problem doesn't ask you to actually produce a sequence, a subsequence that's common, but if you want, basically what you have to do then is to remember which one of these three things gives you the maximum, right? And then you just trace back.